Stars were given to us for a reason, and the stars help us navigate. The really cool thing about the stars is the northern hemisphere stars rotate clockwise around the north celestial pole, and the southern hemisphere rotate counterclockwise. You don't have to have a degree in astronomy to be able to observe the sky and know that the stars are moving in two completely different directions in the southern hemisphere and the northern hemisphere. And I should say, from the southern end of the earth and the northern end of the earth. And these stars are actually divided at the equator. At the equator, the North Star and the South Star, the celestial stars that you look at that are not moving, that the rest of the stars rotate around, those two stars are at the horizon. And as you walk further in that direction, the star raises in the sky higher until you get to almost that exact same location. And like almost until you get to the exact location of the South Pole and North Pole, they're only off by like a fraction. So these are actual videos of the moving stars of the northern hemisphere and southern hemisphere. And you can see that the stars are actually rotating through the sky like a clock. And the way that the stars are rotating lines up with the Bible and the book of Enoch. Even in Job, God talks about, where were you when I tightened Orion's belt? He talks about the constellations. So God knew what he created. Here are the moving stars of the southern hemisphere. And you can look this up. You could actually observe this for yourself in the right location. I believe this video was taken in New Zealand. So here they are moving around the sky. And he just faced a different direction. Now he's looking to the north at the southern hemisphere, and the stars are going counterclockwise. You can actually tell which way you're facing based on the direction that the stars are moving in the sky. It's really neat how the stars work, and they're totally predictable. They do the exact same thing every year, and the stars are the indicator of our seasons. So as the stars are rotating around the earth, you can tell what season we are approaching. The thing with these stars, the northern hemisphere and southern hemisphere rotating in two different directions, they debunk two different things. They actually debunk the globe, because there's no way that's happening on a globe that is spinning in one direction. You would not see stars spinning in 2 different directions as the globe was spinning in one direction. So it totally debunks the globe. But the other thing it debunks is the flat Earth map. The way the stars move in the sky is an observable and repeatable fact that anyone can look up and see what the stars are doing and how they're moving. And Polaris simply cannot be above the North Pole, above the center of the Earth. Polaris would have to be in a different direction in order to make that star actually work the way it should for navigational purposes. It is a navigational star, it can't be in the center. And this is the question we get a lot. Flat earthers cannot reconcile the different constellations in the northern and southern skies. And people have observed this. And there's pictures, there's actual pictures. The northern and southern regions have their own celestial poles, and the stars are divided at the equator and they spin in opposite directions. And the North Star also has a huge void of space behind it. There is no star in the sky beyond the North Star. When you look at the sky, it works exactly like a clock. Everything in the sky is predictable based on a calendar. If you look at the sun and moon, it's telling you the minutes and hours and what time of the day it is. If you observe the stars, they are telling you what season we are in. So everything is like clockwork, and everything is predictable, and everything is observable. I found a great video that explains how the navigational stars work and how you would look at 2 separate stars based on the direction that you were heading. And unfortunately, he thinks we're on a globe, but just picture a map similar to this. This is not the map, but similar to this, and divide it in half at the equator, and the stars are spinning in one direction on the top and the other direction on the bottom. And we'll get into why that happens later, but it's basically because we have 2 magnetic poles, and they're pulling the stars in opposite directions based on south and north.
Ancient travelers and modern sailors and pilots alike would use the stars to voyage through their lands and to discover new ones. So how did they do it? How do you navigate using the stars? Well, first, a quick look at some time-lapse photography will show that the stars are not static in our skies, but instead they streak across the sky as the Earth revolves. Using a moving star as a reference point is problematic, especially for long journeys, so you can't just pick any star in the sky and follow in its direction. The same problem is present for the sun and moon for navigation, as they will move across the sky in a similar way. And while many think they may be able to use the sun, at the very least, to rise in the east and set in the west, due to the Earth's seasonal tilts, it's rare that the sun ever rises in true east or sets in true west. Only on the equinoxes at the equator does this occur, just twice a year. So what's needed is a reference point that no matter the year, month, week, or day will always lead you in the same direction. One last thing before we get started is the stars used for navigation vary depending on which hemisphere you're in, north or south, as the stars in the northern hemisphere can't be seen from the southern hemisphere, and the other way around. So, knowing that, let's get into it. First, we'll start in the northern hemisphere, and here we'll find perhaps the most well-known star for navigation, Polaris, the North Star. By random chance, Polaris sits virtually on top of true north, just a fraction of a degree off, and because of this, it barely moves in the sky, while all the other stars spin around it. This can be seen best best in long exposure photographs where all the moving stars make long streaks through the sky, but at the center is Polaris, hardly moved at all. Finding the North Star is fairly simple too. It's the brightest star in the constellation Ursa Minor, the Little Dipper, or the Little Bear. Yeah, I don't see it either. Polaris is the last star in the handle. If you're having trouble spotting it, you can look for Ursa Major, the Big Dipper, or the Big Bear, which I find much easier to spot. Once you've found the Big Dipper, you could use its in-stars, called Dubhe and Merak, and follow the path they make straight to Polaris. If clouds are covering Polaris but not the Big Dipper, know that Polaris lies roughly 5 lengths of the distance between Dubhe and Merak away. Also, be aware that while Polaris stays relatively still, the Big Dipper, like the rest of the stars, will move, and sometimes may be covered by objects on the horizon, like mountains or trees, so it's best to look for Polaris on high ground. Okay, so what about for going south? Can we just find the North Star and sail in the opposite direction? Well, no. Without a point to aim your ship at, there's no real way to ensure you're sailing in the right direction. Instead, you'll need to find another well-known constellation, Orion. And if that just looks like a bunch of random stars, don't worry. All you need to know is his belt. These 3 close stars in a straight line, Alnitak, Alnilam, and Mintaka. Mintaka comes up again later, so try to remember it. But from here, you'll need to find what's called Orion's sword, which hangs from his belt. It's these 3 stars here, made from a dim star, a fuzzy star, and a bright star. That fuzzy star isn't actually a star, but a huge gas cloud called the Orion Nebula, where new stars are actually being made. If you follow the direction of this sword down to the horizon, this point should lead south. This gets a little inaccurate when the constellation is lower in the sky, but should still bring you south. Okay, now we're in the southern hemisphere, and this is where things start getting a little tough. But considering most of the Earth's oceans are in the southern hemisphere, it's still very much worth learning. Here we'll find probably the second most popular method of using stars for directions, right after Polaris. If you're Australian, Kiwi, Papua New Guinean, Brazilian, or Samoan, you're likely familiar with it already, and that's the Southern Cross, more officially known as Crux. It can be seen as a cross with an extra blemish star right here. Some may find this one a bit harder to find in the sky, as just about any 4 stars can make a cross in the sky, but there's a way to help you find the right one. To the side of the crux, there will always be 2 bright stars, sometimes easier to spot than the crux itself. These are called the pointer stars, and you'll need them again later. The pointer stars always point towards the crux and can confirm for you if you're unsure that you are in fact using the proper stars. After you've located the crux and its pointers, you're going to need to do some more line drawing in your head. Say your sky looks like this. Using the top and bottom stars of the crux, draw a line out from the bottom of the cross. Then, from the 2 pointer stars, draw a line out that's perpendicular to them, going in the same direction as the line from the cross. Where these 2 lines meet is south, so just draw a line straight down to the horizon from that and you should be good. Again, this is not 100% absolutely perfect south, but within a degree or so, and as perfect as things get. Unfortunately, there's no good way of finding north in the southern hemisphere, as Polaris is blocked by, well, the Earth. But there are a few more tricks that you can use in either hemisphere depending on what time of year it is. If you're near the equator, or the celestial equator, I should say, and you need to know east and west, you'll again have to find Orion's belt, particularly the leading star, meaning the first one that will rise above the horizon. This star is called Mintaka, if you'll remember, and the point on the horizon where it rises is always due east, and the point on the horizon where it sets is always due west. And then there's one more easy trick no matter where you are on Earth. First, take 2 stakes and plant them in the ground roughly a yard or a meter apart. Then, pick a star in the sky and adjust yourself so that the stakes align and line up with the star. It helps to pick a bright star that's easy to keep track of. Then, all you need to do is wait for the star to move out of alignment with the 2 stakes. Depending on which way it moved, you'll know 1 or 2 details about the way you face. If the star rose, you're facing east. If it sank, the west. If it moved to the left, you're facing north. And if it went to the right, you're facing south. If it rose diagonally to the left, then you're facing northwest, and etc. Of course, there are many more ways to use the stars, but I think we're good for now.
If we were using a map that had a North Pole and a South Pole in the opposite ends of the Earth, then we could also navigate the same way that they say you can navigate on a globe, only we can debunk the globe because there's no way that the stars are still while the globe is spinning, but they're spinning in 2 different directions. So that is another problem with this map is the stars debunk the flat earth map, and the stars are consistent and predictable. So if we have a flat earth map where we can show how these stars actually line up in the sky, then we will bring a lot more people to the flat earth. And it also aligns with the creator of the earth, God. Thank you so much for watching my video. I hope that you will like and share this video, and I hope that a group of us will collaborate and get the flat earth map exactly the way that it should be. Navigational, lines up with the Bible, and lines up with the Book of Enoch.